you're gonna see that there's a lot of, Voyage has missed a lot. What I mean by that is because a voyage cannot take place at either of the positions, either the start position or the end position. No distress takes place at either spot. Why it's important to you is, let's say I told you that you're going to do a voyage, say that two people are going to go out on a boat, they're calling that they're overdue and they're heading out to a fishing area. Well, historically what the field has been doing is departure point and then fishing area. But the assumption they're making is that they never reached the fishing area, not that they were ever in it. All the distress took place prior to arrival at the last point. So it didn't matter if they put in time error, it didn't matter any of that stuff. They still would never ever go into distress at either beginning or end. There's always going to be in between. This becomes huge as I explain it later on, that there's a big difference there. I'm repeatedly seeing from when I get brought in on a case and they say, hey, let's go ahead and open, what do you think it was doing here? And so if your sectors are saying they've got an overdue, if there's no return leg, you're making the assumption that there was no intent to ever return. Because a return leg doesn't mean that they returned. A return leg means they made the intent to return. They got into distress prior to arriving. Remember, they cannot arrive to that final position in non-distress. So in a voyage, they departed out of a known inlet, head out to a fishing area, and they're coming back to that known location. They got into distress prior to arrival at that end point. So not putting in that return leg would have changed everything. You would have said they would have gotten into distress prior to arriving at the fishing location. But yet this happens all the time. Sectors will create overdues and they will not put in a return leg. And they will not even understand that they made the assumption then that the distress took place prior to arriving at that location. Loiter assumptions, huge. I'm going to explain how to break these down and kind of look at it. But understanding kind of what you're saying by that. Are they hanging out in that area or not? Did you think that they're going to hang out there? Are they not hanging out there? And then how did you break that down? How did you make those determinations? And I'll show you kind of what the system is doing, but you have to kind of think about it. Misunderstanding on how an area works in a voyage. I had a GS, I'm going to draw on this thing quite a bit, just so you guys also can ask questions. But if I have a voyage departing out of an area and going out to a fishing area, there was assumption that that SAROPS treats it like a voyage, and then once they get to the area, it populates the entire area. That's not correct. What SAROPS actually is doing, all 5,000 particles are assigned random locations within that originating position. 50% will be inside that center point, but they're all assigned a spot. And then they'll be assigned a corresponding spot somewhere, randomly. Could be opposite ends, could be completely different positions, whatever, inside that area, with equal probability. So no more likely in the middle or in the middle or not, be 5,000 universal. But they're assigned different positions, and then they're given different speeds based on what you told it. So like the one here might be assigned to go here, and it might be assigned to go at the cruising speed, and so it will, and that's the route it'll take. But this one back here might have been assigned a fast speed, and it might be told to go all the way to here. So when you draw all 5,000s of these, it's going to be from here, kind of in between this cone. But they won't all arrive at the exact same time, because they're all taking different speeds to get there. So there's a big misunderstanding about how an area works, because there was a belief that once it gets to the area, it would just populate the entire area. That's not true. So I want you to understand how an area works in a voyage, because I'm going to show you that once I explain how this is going to work for other things, you'll realize that this is completely underutilized. How we make assumptions on speeds, loiters, what areas, ETAs, all that. We'll talk about all that stuff. So the bad start positions. What I mean by a bad start position. You all have, just like every other unit, you have areas where they start inside of, let's say, a channel. Like this is my land. So you have it, like, hey, we know they departed from here. Don't start your voyage back there. Don't start your voyage until it's getting into open water. Don't landlock a lot of your particles. Don't start till it's outside of the big channel. Because I can just have an OGA search this and tell you it's not there. So this is another problem I see, is that people will do this and then they'll put down like these exact waypoints to get it to follow a channel. But once you have enough air, it doesn't matter, all the particles, it won't drop them anyway over here, because you'll tell it water only, but all you're gonna do is just landlock a whole bunch of particles back here. So move all of your positions out to open water. And if you don't have open water, then you might not be looking at a Voyage. Because if it's all landlocked, all I can do is put an OGA through it and do it that way. All right. So let me give you some Voyage examples. And then I want to talk about what all these kind of things are. So one of the cases I have them do is actually from Buffalo in MSP2. Has anyone been through MSP2 in this room? No? I don't think so. Who's Sector Buffalo? Not here? Okay, that's fine. Then be surprised at them. Very first case we give them is a Sector Buffalo case. Overdue kayakers. 3 kayakers depart out of Golden Hills, I believe it was. If anybody remembers the case, took place a couple years ago. But they tell their loved ones that they were going to go out and they were going to go out and go kayaking. They're supposed to come back. And so in MSP2, I start off and I say, okay, so we give them all the audio files. They get to listen to the reports. These guys left at this certain time. They were supposed to be back by this time. And they say, where were they going to go? And they go, I don't know. It's just out here. It's every kayaker case ever. So you don't know where they went. So what I find interesting from that, let me just draw it again. Sorry, I'm going to do a lot of this because I find it's easier for me to explain it to you all than to try to create a whole bunch of slides. If they depart from this area here, and you know that they intended to stay in this relatively small area, even if you made some assumptions, whether it be a half circle or a rectangle or whatever, but you'd have to make some assumptions on how far would they go. And let's say you do that. What I was seeing before MSP2 is if I asked a room full of people what they would do, I would say that over half would do an area. Because they'd say, well, he's somewhere in this area. And they would do an area with time error, saying from here to here. But you'll see when I break it down that actually isn't going to work very well. And then we're also going to do, I'm going to do a fishing from an area where the guy calls up from an area and says, hey, I'm already fishing out here. I'll be home soon. And then doesn't show up. And that's not as simple as what you think, because in a Voyage, that's not just area from where he starts home. I'll show you how that's going to work, okay? And I'm going to talk to you about, we know they were going to go to a number of different places, but they could have turned around at any point. How do you do that? So we'll talk about all the different possibilities for you. I'm going to log in just so I can make sure that I got that number and done that part. All right. So I told you this one. Vessel would stay within 10 nautical miles of the departure area. I'm going to show you what this looks like up here. You don't have to throw out an answer, but usually I ask the whole class, what are you thinking? Is it area? Is it LKP? Is it LKPDR? Is it Voyage? What is it? Well,
I would have said area before you just went through this. I'm going to say Voyage now.
because I'm teaching as part of the Voyage block. So I know, for all that are paying attention, it's, yeah, I'm teaching as part of the Voyage block. Why would I be talking about it? These are the two options right next to each other. This is the area. This is a Voyage. See the differences? Those red squares are completely impossible. There's no way someone departed from here and got to the edge of their area 5 minutes later. But the area, when given time error, will say that there are going to be particles that are going to be created with equal probability all through that entire thing, even though this thing could not have made those speeds to get to the edges of the area. So this wouldn't work. And if you notice, you end up with completely different corresponding search areas. Like this has pretty much anything here. But when you do it in a Voyage, it says, well, we really want to kind of check the departure area first. Right around it, which makes sense. It's what all of us would do. Right? We do the old Lima Sierra, the old look-see. Go out there, take a look around, see if you see anything. They go, nothing here. And you go, all right. But we start there. But you'll notice that these little particles all only exist because of the possibility of getting to the edge of the area and then back. But so the ones that get to the edge of the area They got into the edge of the area, then they start drifting in distress. So that's why there's none really up here, because all the ones that were going up here, they would have started drifting back. Same thing over here. So what this is remember how they're all assigned a random position starting, right? And then they're all assigned a random position inside the area. And they are all told to go home. Some will get into distress as soon as they leave. Some will get into distress only 1 minute before they get home. But they'll depart out of here, head to where they're supposed to head, and then try to head back. And they'll get into distress at random intervals in between. This is what your actual overdue kayaker case would be. It's a voyage with an area. But so you can see the difference. That's why I think that this is probably one of the biggest misunderstood ones out there. MSP2, we give them the entire audio file. We go through, and one of the things that I teach the SMCs as they come through, which scares every SMC that comes through MSP2. In MSP2, I've got 6 tables, just like we've kind of got here, and I've got 3 people per table, and everybody there is a qualified controller, because it's MSP2, so they're all coming through, they're already fully qualified. What's interesting is that each of the 6 groups will come up with a different scenario for this exact case. Completely different scenarios, completely different objects, completely different POS, completely different everything. And you go, well, that seems, for anybody who's been doing this job for a while, you go, well, that seems pretty natural because every OU is a little bit different. So what I try to do in MSP2 is I try to tell them, break down the methodology. If you break down the methodology, you'll actually create something that makes more sense. And so I'll talk to you all about that today. But the first thing would be, an area won't really work for what you want to do. A voyage would make more sense. You'd be in good company. Like I said, over 50% picked area right out of the bat. So this is a different one. Go ahead.
What is the end point in that sort of voyage scenario?
Back to the departure point. You know that they were intending to make their intent to come back to where they left from. You could also make the argument that maybe they were just trying to make landfall. And if you were to do that, you would just create an area to say, if they get inside this area, they're no longer in distress. You just create your non-distress area and say, go anywhere back to shore. And so again, particles would head out to wherever they're supposed to go, and then they'll head out to a random location along shore from there. So we can do either one.
What's your midpoint?
Say again?
What's the midpoint? Because the voyage, you're doing the voyage, you're going from
Area.
that point to the
This
outer
point
rim?
to the area, back to the point.
Okay. That's all.
And the point can exist inside the area. You could have it that the departure could be here. Departure doesn't have to, it could be anywhere. And it goes out to the area and back. So yeah, this would be point, area, and then back would be either point or area, depending on if you wanted to say they're either gonna make landfall or they're going to go right back where they were. But if we don't put loiter here, then we're making the assumption that as soon as they get to their spot, they turn around and come right back. So this is one of the big ones. This one's not as common, but this one's funky, and I want to show you why it's funky and why it's different. So you get an operator leaving their house, you're heading out to a fish haven to go fishing. You're getting a call from the wife at this point. The wife is saying, my husband went out, he was going to go fishing. Cell phone forensics, he texted me last night in the fishing area saying, hey, I'm out here fishing, everything looks good, I'll see you tonight. And then he was gonna fish all day, but didn't get home. But he was supposed to be home by 2400 Zulu. I'm just using Zulu times to make it easy for you. So one of the things right off the bat is we don't know the size of the bayliner. Is that an issue?
Yeah.
No, yes?
You gotta make an assumption.
Correct, we have to make an assumption. What's interesting about that is that will a 20-foot bayliner or a 30-foot bayliner drift any differently?
Well,
Not the SAROPs, they're identical. Size of the vessel doesn't make a determination in SAROPs, it's the way it drifts. It's a type, only the type. Because based off of what's actually, because a 20-foot bayliner and a 30-foot bayliner, they would have the exact same amount ratio-wise above the water and below the water.
Is that for any class of vessel?
Everything in SAROPs, the size only determines detection, it does not determine leeway.
So wind against the hull is not a factor. Or
It's determining for the wind against the hull determines its leeway and its
Yeah.
leeway rate. The rate is assigned by the actual type, not the size. way I draw this, it's kind of rudimentary, but I'll show you. If I draw a boat and I draw the water, here's the wind, here's the water, right? If I change the size of this vessel, what's above the water and what's below the water don't change ratio to each other. So as the leeway rate increases, so does the drag. That's why in SAROPS they're treated the same. So a 20-foot boat will drift the same as a 40-foot boat. But the 20-foot boat's harder to see than the 40-foot boat. So there'll be those watchstanders who go, well, I don't know what to use for the bayliners, so they'll start really trying to figure out what they should be using, and they'll say, well, I'll default to a 20-foot just because it's what the addendum tells me. But the truth of it is that you could call it a 16-foot bayliner if you're not sure. Because they're going to drift identically, but the 16-foot's going to make it harder for detection. That's all it's going to be. So don't get wrapped around the axle on thinking I have to know the exact size of the object I'm drifting, because you don't. So there's where we're departing out of the home, heading out to a fish haven. Okay? So again, using what we've talked about, you would not have it depart out of here. Anywhere along here. You would have them depart out of here. And we would just have somebody check this back area. But we wouldn't actually need to search that because it's all going to go right here. We'd still go from here up. Then I get this whole thing about hazards. So there's a big conversation about what does hazards do? Should I put hazards in? Should I not put hazards in? And so I wanted to make sure that it was cleared so that way if anyone wanted to write it down or understand it, is that the low, medium, and high intensities just change the probability of the hazard creating distress. Remember I told you they were randomized? Well, if you think about it, if I give you the hazard, when a particle's inside that hazard, if it's a low hazard, they're 3 times more likely to go into stress. Medium 10, high 100. And if you put a low on top of a medium, then it'd be 30. So why that's important is because do not overlap hazards. It's like the Ghostbusters, do not cross the streams. You don't want a multiple of a multiple. Just be clear on like what you got. Like, okay, 10, 3, whatever I'm going to use. Okay? All right, so this is what I picked for this drift, just to show you. So I got the cuddy cabin, swamp capsized boat, PIW with PFD. We'll get into that in a little bit of what that object means in boating debris. I just put all of them in and just said, okay, good to go. So the way that most people would have done this, we'll draw again. Told you. This is why I needed a whiteboard. Told you there'd be a lot of drawing, because without that, it's hard to conceptualize some of this stuff. We have the fishing area offshore, right? And the guy was supposed to be heading back. So we're making the assumption then that he was in that area at the time of the cell phone. So we have cell time. But he was due back here by 2400. So the way that most people were doing this is that they were using an area and using distress or using a time interval. So they were picking area for the start and saying, okay, well, anywhere from the time of the call, let's say 1200 Zulu to, and they were picking like 1800 or 2000 Zulu. And so they were picking distress interval, like, well, not distress interval, but time interval for the area. So this is what I was seeing is that the majority of people were doing is they were picking a time and they were saying, okay, and then they're going to go ahead and pick the time home, and then they're using the speeds that they got, the 10, 20, 30 kind of thing. But these ETAs don't make sense. There are 3 ETAs in any voyage, and every CDO should be looking at these. When you get an overdue as a CDO, you've got one of 3 things. You've got 3 constants. You've got speed, you got loiters, and then you've got ETAs. I would say, what, 99 out of 100 times, nobody knows what speeds they make, and they don't know how long they plan on fishing, but they know what time they're supposed to be home by. So these have to make sense. If these ETAs don't make sense, then your voyage is wrong. Because that's the only constant, that's the only thing that you have as fact. So I'm looking at this and I'm going, well, the latest ETA is close to the 000, but my expected ETA is 19, and then my earliest is 1430. So right off the bat, as a CDO, I would know this isn't really tracking for me. But the other key things I'd be looking at is total voyage distance. It's only 14 miles from there to there. So this would be my like, this doesn't make sense. Because none of these ETAs are gonna line up. But I wanted to make sure you all knew that there were 3 ETAs, based off different speeds, based off different loiters, based off what you're ever gonna do. And so a lot of people were just skipping past this, not realizing that really what they should be looking at is this one. This ETA is their expected ETA. They maintain the standard cruising speeds, do the standard loiters, this. These are utilizing like, hey, using that fastest speed, or hey, using that slowest speed, or whatever. Then it's, so you're kind of narrowing that window as best you can, okay? Loiter can't be added from a departure point or an end point. Remember I told you, distress takes place between the 2 points. So keep in mind, I create this, none of them get into distress in the area. They would get into distress in a transit from the area back. So you can see how this is wrong right out of the bat. And there's your drift. And again, majority of the Coast Guard would do exactly this. And then they would end up searching pretty much right here, which doesn't, I mean, that's not bad. We're gonna search the intended voyage route anyway. But I'm gonna show you that if you do it correctly, this is a completely different drift. Because we know he got in the fishing area because he texted us at 1000 local. So I'm starting at 1400 Zulu. But then what you're gonna see is I did an area on top of an area. And you're gonna go, that doesn't make any sense. And I'm gonna go, you're right, because the way that the system works. And you're gonna go, what in the world did you do, Chief? And I'm gonna go, yeah, so let me show you. What if I put an area on top of this area? Exact same thing. And I tell startups, I know you can't get in distress at your original area. I need you to get to your second area as fast as you can and then loiter. So I'm kind of tricking the system. I'm telling it, hey, you might have a point that starts here and it might end up here for once the area's on top of itself. It might have to try to transit it within its own area. I don't want that. I want it to get to its spot. Just give me the 5,000 particles inside the area all hanging out as soon as possible. So I adjust that transit to say, I don't want this to take any time. So I make it like 100. So what happens in the system is it creates a boat, but then immediately, like minutes later, that boat's over here. And now that boat will start to loiter and hang out in that spot. Because I couldn't get it to loiter from there. This is one of the things I want to change in the system because nobody knows it does this. So it goes there, hangs out there, and now it's loitering. And what that means is that there's a chance now, from the entire time he's out there fishing, there's a chance that he's actually going to get in distress then. This is all the distress particles that are taking place back in the originating area because he's there fishing for hours. When you put these two next to each other, and these, if you look at these ETAs, they're much better now. This is 2340, this is 0130, so only an hour and a half later than what he said, and this is only an hour and a half earlier than what he said. So I've got it down to a window of 3 hours, but my expected ETA is within 15 minutes of what he said. I feel pretty good about that. That's much better.
Chief, I have a question.
Sure.
Can you do a OKP with a large error and then an area?
You could. Same idea, but I'd still want that high transit speed. Key thing is I want to get him inside the fishing area as fast as possible and loitering.
Right. Well, I mean, hopefully we would be able to get cell phone ping and have an LKP to an area.
Mm-hmm. But even if you had the cell phone ping would only be active as of the time of the ping, which still could be right. So I mean, there's still a good idea to still say, okay, we'll use the cell phone forensics and give us a ping there, but then keep it somewhere in the area, or even just an LKP on top of itself would still work. Right. But understanding that you cannot loiter on that first position. You gotta use it on the second position. Yeah, which is funky, but there's another way that this works though.
Chief,
Good.
I'm still struggling with why you have to increase the transit time to go. If you're going to do a voyage from an area to a point,
Mm-hmm.
Why not just do an area to a point without changing the transit speed?
So, good question, so I'll explain it again. So keep in mind that, remember, all of those positions of those points and particles, right, all have different assignments from the first area to the second area. So in the first area, they might be assigned this position, but come the second area, they might be assigned this position. So what it means is that it won't loiter until it gets to that spot. So if this is miles, it could take it a long time to get there. And I really don't care about that. Like, cause this isn't part of the whole transiting or anything else. All I want them to do is get into their spot and loiter. So to do that, I can just increase that transit, make it 100 knots, 150 knots, however you wanna do it. But so as soon as this thing goes, it goes, boop, I'm here. And then it loiters. And this is why I don't like this way. This is a very cumbersome way, but this is absolutely how the system works. Go ahead.
So question.
Sure.
So let's say the cell phone ping came back for 1000 when you did text, and you have a position. So could you make that like to an LKP and then make that essentially an area after that? Because
Yep.
then he's in the loiter area,
Yep.
but he's already there.
So let's assume that we have cell phone forensics that put us here. Are we 100% accurate that the cell phone forensics is accurate to a mile, even though we're still almost 12 miles offshore? We could say that, sure, maybe.
Well, should have that information, right? It
They
would
should.
depend on the cell phone company
And they're always accurate, right?
within an area.
True. So I'll give you that. So that's what I mean by, you could create the LKP, and you could still create an LKP on top of it. But creating the LKP with a cell phone, if you just gave it time error, again, it's not loitering. They're just gonna go from that LKP to the other LKP and get into distress in between. Go back to the very first thing I said, it's between the two spots, never at. So if you want them to consider the possibility of at, you're gonna need to put the position on top of itself.
Right.
So it
Like
could
an
be-
area on top of the position.
You could, absolutely, or even two positions, an LKP on top of an LKP. Both work.
Okay.
All I'm trying to do is to tell you that really focus on the second one should be where you want them all to be.
Before you go into distress.
Yeah. Clear as mud so far? This one's kind of funky.
Well, you're basically trying to figure out a way, a place to put the search assets with
True.
the idea of finding the object that we're looking for with
Yeah.
the scenario we've been given.
And understand that, I'm gonna get into that later, because this isn't necessarily saying what I would do, like that I think we know what we do out the gate with this case. We're gonna tell the transit the intended route. We almost always do. You get an overdue, you say, okay, well, he left out of here and he's going there, then I need somebody to do that.
Yep.
And check that, and check the area. But when that comes up neg res, and you end up going, okay, now what? If you were stuck with the other one, you were searching in between, and that's all you were searching. You didn't have hardly any particles that were up here. And that's what I'm saying, is like, you're right, I'm looking at it from the SRU standpoint, and I'm gonna talk to you more about that, about what my alpha and initial actions are. And it won't be based on this. I'm not gonna ever say, hey, SAROPS, go out and do that instead of searching this first.
Well, I think what I'm saying is, I think a lot of us probably minimize the role of SAROPS, or the role of the Voyage scenario in SAROPS to help us put those assets in the right location.
Yeah.
And using the Voyage scenario in a situation like this is a better alternative because it allows you to put the assets in the right location easier.
Yeah, no, it's a good point. And keep in mind, a Voyage scenario is one of the few scenarios that actually has pre-distress motion. So it's the object moving like you told it to and creating distress as it goes. So it's one of the few that actually is going to move as it creates distress. The rest of them are static shots. This one gets weird, so I'm going to show you another way to do this that is easier but more dangerous. Yeah. Because you could do it as a distress interval. Let's go back to our original idea. What if I gave the entire voyage? Let's go back and just recreate everything. The part's out of here, going to fishing area, going back. I could create the loiter then, because the loiter now is the second spot, right? But we know that he didn't get into distress from here out to there. We know he got into distress once he was in position. So I could use the distress interval to say, hey, begin right around the time of the cell phone forensics and end by this time, by the time of the new day. So SAROPS will then say, okay, it won't have any particles going to distress prior to that, and all the distress will take place between those two times. Now you go, oh, that's much better to what I want. But very few people would have ever recreated the entire voyage and then used the distress interval to narrow down the distress window. The reason why this is a problem is this last big part. I just got a call, actually, it was really funny. I was in the middle of labs. One of the instructors came into me and said, hey, one of the sectors having a question on distress interval and it's not doing what they thought. I knew exactly what happened. As soon as I got him on the phone, I was like, you did this? And he goes, yeah. I go, yeah. So what I mean by that is that this time, if this end time is too far out, like if you made the end time, you just go, oh, whenever SAROPS, I don't care. And it ends up being past when all the particles were already in distress anyway. SAROPS goes, you fat fingered this, and it just defaults to total time. So it doesn't have a way of saying, oh, no, I really meant that. This, if it happens before that, it's okay. But it has to be between two points. It cannot happen, this last point, this last time, cannot be after everything should have arrived already. This is why I said it's more dangerous. It's easier, but it's more dangerous because it could still default out to total voyage.
Will it tell you that it defaulted out?
No, which is why I'm wanting to fix this. This should, I've put in a request that when they do this now and it defaults to entire voyage, you should get a pop-up saying your stress interval times need to be looked at. But until I get that, you won't know, unless you look at it and you'll realize all the particles are there.
When you just run your time slider to see that the particles didn't start drifting till
Yeah,
after they hit the
you
air?
could do that, absolutely. And you'll see it because it'll be the entire leg, it won't be just one part of it. But you're gonna go back and go, what in the world, why did it do it? I just put in a distress interval, that's why I got the phone call. They're like, I've been doing it and I keep doing it, and it's not doing it. And you go, great. Because your end time has to be before all those guys were supposed to get home and be safe.
Right.
It has to be between a window, not after the window. So this one is easier, but like I said, it's more likely to cause a problem, I think. Why this is important, to your point. SRU focus. SRU focus in SAROPS here versus SRU focus here. After alpha, SAROPS will start focusing in the offshore area. Here, it's not going to focus here. It'll focus here. So if you do your simulation wrong, I don't know that you'll catch it for how long and when that it did it. This is paramount for the districts because you all are the second set of eyes. The sector's looking at you going, hey, did we do this right? And you open up the SAROPS and you go, you look at all the times, you go, yeah, it looks good. And so they really need somebody to go in and go, I don't know, the times aren't making sense to me. Let me look at it again. And you hopefully can remember some of these things we're talking about to go, oh yeah, that might be, those times could be off. Because those won't be the same. Alright, so let me pull into this because I want to show you some of the stuff in SAROPS. I want to go through all of the buttons as we need to go through buttons. And I've talked for almost an hour, so how about we take 10 while we do this part? So we get into here and you've got a lot of different options into voyages. Okay, a lot of different options into a lot of different things. I'm going to show you. It's going to be easier actually if I create one up. I want to show you how we break down and look at the ETAs and make assumptions. Believe it or not, while you were in school, you probably don't remember because that whole morning you had with me, and you're like, I don't remember. We learned so much crap that day. I know. But one of the things I had you do was do a voyage when you didn't know the speeds or you didn't know the loiters. I had you do one because I wanted you to learn that you have to be able to calculate loiters and figure out how to do loiters if you only have one or the other. If you have a speed or you have the loiter, you should be able to figure out the other one. So, let me open this one up. So this is a voyage in which we know that the reporting source was due back at home by 1700. So if you notice, my ETA is 3 minutes off. So it's pretty darn close. Why that's important is because we knew the speeds. We had a good approximation of speeds based on the type of vessel and what it was. And when they opened up the reef, they could create the loiter time. If you have 0 for a loiter time, this ETA will drop by exactly 5 hours. Because they put in exactly 5 hours of loiter time. That's how easy it is to tell. So if your ETAs are not matching what you need, and you have no loiter assigned, then you're making the assumption that they are not hanging out in that spot. They're going to leave that spot as soon as they show up in that spot. So use speeds and loiters to help you figure out and get that ETA where you want it, to get that sweet spot. Like how long are they hanging out there? So you know that they're making certain speeds. We're going to make certain assumptions based on the type of boat it is or based on the size of the engines, however we're going to do that. And then we're going to use that to help determine our loiter amounts. How long are they hanging out there? How long are they staying in that area before they come back? If you're doing all that right, this expected ETA will match closely to what they're saying. And then you know that the SAROPS is simulating pretty well what they actually did or intended to do. And then the latest and earliest can be based off of whichever you want to do for a number of possibilities. I am a fan of putting in the lowest speed as 1 to account for the possibility that my Voyager is just limping home. And then I can tell whether or not Sarops is telling me they should have been home by now, even making only 1 or 2 knots. Maybe I'll make assumptions on that. Because let's say that you had let's say that they're supposed to be dumped back by 1700, but we had a squall come through at 1900, 2 hours later. If we do that with a hazard based on what we've got here, the latest ETA was before that 1900, so that squall wouldn't even affect them whatsoever. But if I think they were limping home, that squall absolutely would have affected them if they had no power or if they were limping back. So I will put things like that into account for those possibilities to say, hey, if I think that they're only going to make a minimum speed of 2 knots, 3 knots, 4 knots, whatever, I'll put that in as my lowest, my minimum. I'll leave my cruise as to what do I expect. And then the max, I usually look at the max based off of what I think they're going to be burned. You know, what's the burn rate? Like, because what if they don't leave till late? Do they wait till they're late and then they throttle down to go home? And if that's what happens, then you're going to want max to be whatever their actual max speed would be. That's just based off of, you know, whatever you can find on the vessel.
What's the 1 knot do to your search area? I mean, what's the 1 knot do to your search area?
So what's going to happen is that you're always going to end up with some that are going to, you want to do it only on the return leg. Don't change it for everything, only the return leg. And so what you're going to see is as they depart out of an area and go back, you're going to see them creating those little particles still behind it. As to how much it's going to affect the search area, not a ton, other than the fact that you might have some that still aren't in distress based on the latest ETAs.
Well, now, but so when I look at that, if you're doing 1 knot, you're 21 miles offshore, you're 20 hours getting in.
Mm-hmm.
So your time period is much greater than 20 knots.
Yep.
So you're going to be affected by weather and drift much more.
Yes.
It's going to increase the size of your search area.
It should over the long run, but initially, we're only a couple hours in, so it's only been a couple hours of drift anyway. But you're right, as we go forward, it's still going to be creating this. So maybe for alpha, if you wanted to say maybe even a minimum of maybe even 5 knots, because I might want to know what if they had suffered a casualty, where would they be right now, approximately? So you could do the 1 knot, you could do 5 knots, you could do a number of things, but the minimum speed doesn't necessarily have to be what you think they're going to make at a minimum, especially on the transit home. Because that's what we're finding. We all know this. The majority of the problems are happening when they start the engines again from their fishing area and try to go home.
How is that going to affect, are you going to get that error message of saying not enough time is in your search parameters of saying like you need to extend it out? Like he said we use example 20 miles
exactly.
an hour.
So like SimEnd might not even have it. It might still say that your vessel's not even in stress yet based on that. So that's where I'm saying also I would adjust those.
But as Carl was saying, that's going to skew your search area. So you're saying you do the minimum at 1 knot, and what are you saying are?
I'm saying I throw in 1 knot as I go forward. Let's say that I've only been a couple hours late. Let's say we're only 2 hours overdue. I need to create a minimum that's going to get them back to the overdue point now. See what I'm saying?
Okay.
But as I go forward into Bravo and Charlie, I can then go back and say, let's say that they were even going even slower than that.
Gotcha.
Now I'm going to increase some of that search area because I want to then start focusing on the other areas we haven't searched yet.
Gotcha. Okay.
Not right out of the gate.
Not out of the initial
Yeah,
one. Gotcha.
yeah.
All right.
No, I'm glad you said that. I'm glad you asked. So I would look at a number of possibilities right as we start. Now, this is a 2 scenario because it's a, hey, he either went here or he went here. I bring it up to the class and I brought it up in MSP2. If somebody told you, hey, they're going to go fishing in either the north spot or the south spot, most people turn around and say that's 2 scenarios. And I have to argue with them that's actually 4. And they go, huh? And I go, he either went north. What happens if the fishing is bad at north though? He goes home? And then I'll go, no, he goes south. And I said, that's exactly it. So he goes north and home, he goes south and home, or he goes north then south and home, or he goes south and north and home. 4 scenarios. Do you think that if I gave any of you that training option of, hey, he goes here or here, all of you would create 4 scenarios right out of the spot? No. And that's what I was finding from the fleet. So what's happening is that you don't put anything in between. And then I end up with some people who will put in both spots. They'll put in, oh, well, then the voyage should be out to north, down to south and back, or down to south and up to north and back. But that doesn't account for only south and only north.
Right.
I'm trying to show you that multiple scenarios are going to help you come up with more possibilities in your search area. And where those multiple scenarios overlap would be where you really want to spend the majority of your effort. So I'll talk about that more. Okay?